To keep track of churn is one of the vital metrics for businesses. The topic I want to cover today is customer churn analysis. We are going to analyze the behavior and purchasing patterns of customers, build measures, track lost customers, and calculate the churn rate in a dynamic period using DEX. In the first part, we will perform a spending analysis and investigate the spending behavior of the customers. In the second part, we will identify new and lost customers and calculate the churn rate. The Excel file I had was a flat table containing all the data. I cleaned it up in Power BI and built up a simple data model to help us to solve the problem. I created a date table and built an active relationship between date key in date table and order date in sales table. If a filter placed on the date table, it follows down through the relationship to the sales table. The model follows a star schema with the fact table in the middle and 5 dimensions that have one-to-many relationships with the sales table. When I create a filter on a sales order table, it will also filter the corresponding rows of the sales table. I built a very simple measure for total sales. Next, we want to compute the sales amount for all the dates up to each month, depending on the selection of the slicer. To achieve this, we can utilize the quick measures to get the running total. However, first I want to write my DAX code. We have one filter coming from the visual and two outer filters coming from the slicers generated by the user interface, which filter the data by country and year and enable us to find out the total sales for each year in a selected country. To retrieve the last date of the current context, we use max and store it in a variable called current date. Last date as a time intelligence function can also be used, but it is a table function designed to be used as a filter in calculate function. Whenever we have a table containing one row and one column, it can be automatically converted to a scalar value, but it comes at a price. A better implementation is to use max to retrieve the date instead of using last date. Max and min are not table functions, they return scalar values. We have outer filters on the year coming from the slicers. I use are selected to remove filters on the date column coming from the current query, while keeping the filters coming from the outside. Using the is_on_after function, we can place a filter on a date to be less than or equal to the current date and then call are selected. This function looks at the entire date column in my date table and shows me only the dates until the last date of the month I am on. By slicing a year, the running total sales in my report starts from the selected year and accumulate over time. This is useful for tracking our company's growth over time, including this selected year. However, if needed, you can modify the code and have the running total from the start date in the sales table. We determine the amount of money customers spend per year. Additionally, we can calculate the average sales across all countries per month. The average function iterates over the countries, take the total sales country by country and calculate the average. If we select one country, the average sales by country should be the total sales of the selected country. Next, I created a field parameter to dynamically change the dimension of the visual. The report reader can dynamically update the bar chart by selecting the field in the horizontal slicers over the visual. If you are not familiar with the field parameter, you will see a link in the description below. It is quite simple. You can go to the modeling, click the drop down and select field provide a name for the parameter and select the dimensions that you want to add to the slicer. Once you have done that, a new slicer will be created and you can then drag and drop it into the visual. Now I have the options to choose country and category. The bar chart shows total sales by product and country based on the selection in the slicers. Now we can gain insight into which countries are driving the most sales for our businesses and identify potential areas for improvement and expansions. Next, we aim to identify big spenders using a dynamic threshold. To achieve this, I have created a parameter called threshold. The threshold parameter has a minimum value, a maximum value, and increment of 100. Customers with total sales exceeding this threshold are considered top customers. I filter customers whose total purchases is bigger than a certain threshold and calculate their total sales. I drag and drop customer key and name into rows and rename customer key as top customers. When we hover over it, we can still see the original source field. By clicking on the plus symbol, we can expand and see the name of the customer associated with the customer key. We can also slice by country and see the top customers for this particular country. By looking at the customer IDs for the big spenders, we can conclude that all customers spending more than 30,000 are from France. Tree maps and sunburst chart provide a hierarchical view of a data and are good for identifying trends for large hierarchical datasets. You can import these visuals directly from AppSource. To do so, select the ellipse from the visualization pane, choose Get More Visual, and search for it. The sunburst chart allows me to show multiple levels at once, with a hierarchical representation of group and region based on the total sales. From the visual, we can conclude that we have top-level branch from bike subcategories: road bikes, mountain bikes, and touring bikes. Additionally, it is evident that Southwest in North America generate the highest revenue compared to other regions.